According to the standard model of cosmology, approximately 13.8 billion years ago, the Big Bang happened, and the universe has undergone non-stop expansion ever since. Expansion would mean that massive objects are moving away from each other. This means that the galaxies we observe outside our Milky Way are moving away from us. To measure how far a galaxy is from us, we use something called the cosmological redshift. In a nutshell, the higher the redshift, the farther away a galaxy is from us. Now, light from distant galaxies takes a lot of time to reach us, which would imply that the more distant a galaxy is, the earlier in time we see it. But there is a problem. Light from galaxies far away stretches into infrared wavelengths, which the human eye cannot detect. The Hubble Space Telescope can see only from ultraviolet to near-infrared light, which is why it rarely found extremely distant galaxies, GNZ11 being one of them, that is shown as it existed 13.4 billion years in the past, just 400 million years after the Big Bang. This galaxy has a Z, or redshift value, of 10.957. This made astronomers think that there were very few galaxies beyond redshift 11. Now here comes the James Webb Space Telescope, which can see in infrared, and objects at redshifts 11 and above can be detected only by infrared light. So what next? Well, we launched the telescope and pointed it towards the heavens, and voila! A very different picture of the universe started to emerge from the depths of time. The telescope revealed dozens of galaxies that could be among the earliest known galaxies in the universe. Using early observations from the telescope, astronomers looked for galaxies at very high redshifts, which would indicate that these galaxies formed earlier in the universe than expected. As the telescope scanned the cosmos, NASA detected several galaxies that may have been the first to appear in the universe, about 200 to 300 million years after the Big Bang. Very soon, it discovered the oldest galaxy in the universe at a redshift of 13.2, the Glass Z13 galaxy, which was formed just 300 million years after the Big Bang. Finding such a large number of galaxies in the early parts of the universe suggests that we might need to revise our previous understanding of galaxy formation, said the lead astronomer of the finding at the University of Missouri. He also added that our finding gives us the first indication that a lot of galaxies could have formed in the universe much earlier than previously thought. While the new discovery took the whole scientific community by storm, another primordial galaxy showed up, this time existing only 390 million years after the Big Bang. This was back in August of 2022. Cut to the present, and now with the help of Webb, we have found more of these high redshift fully formed galaxies. And not only are they fully formed, they look very, very different. Yes, two more most distant galaxies ever seen have been spotted by the eagle eye of the James Webb Telescope. The first one, designated Uncover Z13, has a redshift of 13.079, confirming we see it as it existed just 330 million years after the Big Bang. The other galaxy recently discovered, Uncover Z12, has a redshift of 12.393, placing it at just 350 million years after the Big Bang. But what sets these two galaxies apart from the rest is their appearance. While other galaxies seen at similarly high redshifts seem to be point-like, indicating they are very small, the uncovered galaxies, strangely, have structure. Previously discovered galaxies at these distances appear as a dot in our images, but one of these two appear elongated, almost like a peanut, and the other looks like a fluffy ball. But that's not all. These galaxies are also bigger, with Uncover Z12 sporting an edge on disk, about 2,000 light-years across, which is 6 times larger than other galaxies seen in that era. While these early galaxies are expected to have formed out of similar materials, they are already showing signs of being very different from one another. Interestingly, the James Webb Space Telescope has the ability to see even higher redshift galaxies. Currently, there are about 10 more galaxies that the SEERS team is now evaluating, which could be even older than Maisie's galaxy. We're seeing a rise of massive galaxies faster than we previously thought, said Fabio Pacucci of the Harvard-Smithsonian Center for Astrophysics. The ages of some of these early galaxies are estimated at just tens of millions of years. This could have implications for large structures of dark matter known as halos that, according to our cosmology, sculpted early galaxies. Yes, some problematic and potentially model-busting early universe candidate galaxies still remain, and the first among them may be a class of galaxies identified by a team of scientists at the Swinburne University of Technology in Australia. The team found galaxies with billions of solar masses, comparable in weight to the Milky Way, from just an estimated 750 million years after the Big Bang. These galaxies are 10 to 100 times bigger than galaxies previously seen in this era, and are packed into structures 30 times smaller than the Milky Way. What is more intriguing is that the galaxies seemingly are hosting many more stars than we thought would be possible. Indeed, the very fundamentals of our understanding of how massive structures build up over time has challenged the cosmological standard model. Remember what Michio Kaku had said last year after these very early galaxies showed up in Webb images?
Well, that's the problem. The James Webb Space Telescope is upsetting the apple cart. All of a sudden, we realize that we may have to rewrite all the textbooks about the beginning of the universe. Now, it takes many billions of years to create a galaxy, like the Milky Way galaxy, with 100 billion stars, many billions of years old. But the James Webb Telescope has identified 6 galaxies that exist half a billion years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. There should not be primordial galaxies that are bigger than the Milky Way galaxy that are only half a billion years old. Something is wrong. We may have to revise our theory of the creation of the universe.
That was from last year. Not only did we discover more distant galaxy after that, recently, Webb detected Milky Way-like galaxies at the edge of the universe that, according to our physics, should not exist. Many early galaxies, like the ones the JWST detected, were rich with glowing gas so bright that the gas itself could outshine stars emerging from within. These new findings reveal just how common such shimmering, infant, gassy galaxies were when the 13.8 billion-year-old universe was around only 2 billion years old. Observations now reveal that almost 90% of the galaxies had so-called extreme emission features, meaning they exhibited all that glowing gas. And while studying these early galaxies, astronomers stumbled upon the most distant example of a galaxy in the universe that looks like our home galaxy, the Milky Way. Yes, you heard that right. When the universe was just 2 billion years old, the newfound spiral galaxy, SEERS 2112, appears to have featured a bar of stars and gas cutting across its heart. But wait a minute, how is that even possible? Our galaxy, the Milky Way, is also a spiral galaxy sporting a similar bar. Scientists suspect the Milky Way's bar rotates cylindrically, funneling gas into the galaxy's center and sparking bursts of star formation. Astronomers previously thought this galactic structure marks the end of a galaxy's formative years, so it was expected to be seen only in old galaxies that may have reached full maturity, perhaps those that existed halfway through the evolution of the universe. And with the Hubble Space Telescope's past observations of galaxy morphologies, we thought the early universe hosted very few barred galaxies. However, everything that we know about the early universe is changing. The new findings gathered from data by the Webb telescope conclude it may not be necessarily true that barred spirals must have existed only recently in the universe. The discovery of spiral galaxies SEERS 2112 reveals galaxies that resemble our own already existed almost 12 billion years ago, when the universe was just 15% of its current age. Yes, Cirrus 2112 is observed at a redshift of 3, when the universe was 2100 million years old. Essentially, this means the light from the galaxy took almost 12 billion years to reach the James Webb Space Telescope. This is a surprising find, as galactic bars seen in the galaxy are thought to have manifested about 4 billion years into the birth of the universe. The standard model of cosmology predicts that the early universe's physical conditions must have prevented the formation of such barred galaxies in general. But here we are. Not only that, even theoretical predictions from cosmological simulations really struggle to reproduce such systems at those epochs. So what is going on? We now need to understand which key physical ingredient is missing in our models. If something is missing, said one of the scientists associated with the discovery. Now, if you think this is it, here's the crazy part. Scientists believe that 85% of all matter in the universe is dark matter, a mysterious substance elusive to observations because it doesn't interact with light at all. Dark matter is thought to have radically influenced galaxy evolution and star formation from as early as 380,000 years after the Big Bang. Our reach.